Hello everyone, thank you very much for watching this new event, lesson 8 from the Spring Reactive stream, and today we are taking a look on WebSockets. So let's discuss some examples of what WebSockets are and implement some applications using WebSockets. If you are watching the event live, don't forget that you can ask questions in the live chat or start discussions there. If you're watching the event recorded, you can still ask questions in the comment section, or you can find me on LinkedIn or Twitter. With that being said, let's go straight to the subject. First of all, I would like to create a diagram to make sure that before starting with the example itself, everyone understands what a WebSocket is. So I prepared here my board where I will consider this as being a client. And of course, I will need something to represent my server, because WebSockets is in the end a way that we use to implement communication between the client and the server, between clients and the server. So what happens is that in case of a WebSocket, a client first has to start a session. We call it a session. It's basically the intent of the client to start communication. And then, so this is the client and this is the server. And then once a session is started, then the client and the server can exchange messages. So one of the things that you will find different about WebSockets is that unlike in the case of a normal endpoint, you don't have a request from the client and then the server sends some events and then it closes the communication. Unlike that case, you can have through a WebSocket, after a session has been started, multiple messages broadcasted to the clients. So I can represent them like this with arrows, and the clients are the ones to decide when they disconnect from the session. So if they disconnect, of course they won't receive the messages anymore. Otherwise they can connect to that WebSocket and then they will receive the messages sent by the server. And it's also the fact that the clients as well can send signals to the server. So it's a bidirectional communication. But in the case of WebSockets, we are rather more concerned about the messages that are sent the other way around, and I will explain immediately why with an example. But the first thing to understand is that WebSockets represent a way in which a client and the server communicate. So what should I do now is start, of course, an example for you. So let's start an example in IntelliJ. How do I usually call it? I think it's Spring Reactive C8, it's lesson 8, and then the first example here. Let's use Java 17 because it's the latest now, but it's not that relevant. We are using the latest, but I'm usually doing that. And then, of course, the only thing we need is to make sure that we add the Spring Reactive dependency and start the project. I will have probably to wait a few seconds for my IntelliJ to download and index all the dependencies that I've added. But as you have seen, fortunately, the only dependency I need and I've added is the reactive web one. So I'm going to start with a very simple example, and the first thing I would like to be able to achieve is have a server that accepts session openings or WebSocket session openings and send messages back to the client. Then I will show you what you can do to get messages from the client as well. And this will be a very simple and more theoretical example. And then we will discuss about some scenarios that will happen in the real world out there. So where you will, for example, really create a WebSocket, and why will you create a WebSocket for. So WebSockets are generally pretty simple to configure. Of course, we need a configuration class. As usually, I create configuration classes in a separate package, and then I will call this, let's say, WebSocket config. Not necessarily really relevant how you call it. WebSocket config will do it. And of course I have to make it a configuration class, and then I have to configure two beans. That one of them is the simple URL handler mapping. So I will say simple URL handler mapping, whatever the method name. This will allow me to link the URL to a specific session. So I might have multiple URLs linked to sessions, and in this case I would just want to have a URL that the client will use to open a session with the server. And then I need a WebSocket handler here, WebSocket handler, and this WebSocket handler, so then I will simply return a new simple URL handler mapping, and I will use a map to specify that, let's say, the path WS messages. I use this prefix WS from WebSockets. This is linked to this WebSocket handler. And then very important is not to forget to give it an order, otherwise it will not be taken into consideration. So Spring will basically not accept the client to use this specific resource that you put here. So make sure you don't forget the last parameter here, which is the order. And then I have to make it a bin, so I will use the @bin annotation over the method. And then of course we need a WebSocket handler, so you see that it tells us that it could not auto-wire a WebSocket handler. So I think you have already figured out that the next thing that I'm going to do is to provide the WebSocket handler. So then of course I will need to use an object of the type WebSocket handler adapter, and then I will have to create a specific bin of type WebSocket handler. And this is an interface, a contract that Spring understands, and through that contract we will be able to provide an implementation, and the implementation will of course say whatever we want to happen on that WebSocket. So it's pretty simple. So the first thing, just not to forget, let's add a WebSocket handler adapter here. We will need to add the WebSocket handler adapter as a bin in the context as well, and this will be the link of the WebSocket handler we create to the mechanism behind the scenes. And then I usually create the handlers as separate objects in separate packages. That's how I normally work, because I prefer to separate the responsibilities in a way in which my application is easy to understand and maintain, and that's something you have seen also in the previous lessons. So that's why I will create a package named handlers, and in this package I will add my handler. Let's call it custom WebSocket handler. Okay, and this custom WebSocket handler will implement WebSocket handler, and of course once it implements the WebSocket handler, it has to override the handle method, which we will implement and which will basically define what exactly this WebSocket does. And it won't be a bin in the context unless we use either stereotype annotation or make it a bin through the bin configuration. So in that case, let me choose the first, which is using a stereotype annotation. Since is a custom class I created in my project, you know from the Spring fundamentals that is more comfortable to use the stereotype annotations in that case. If we go back to WebSockets config, you see that the error disappeared because now we really have an implementation. We really have a bean of an implementation of type WebSocket handler. So that's basically what we do here. In this case, we take the only implementation which is defined by this class that created an instance in the Spring context, and we map it to this path ws/messages. The path is at your choice, of course, and you can have different implementations and different paths in case you need that. Maybe you have different WebSockets that do different things. So that's basically it. Now, of course, it won't do anything unless we really make it do something. So the whole thing goes here in this WebSocket method. So the only thing we need to make sure we do is to actually, in the end, send the flux. So what we'll basically have here is the send method, and the send method needs a publisher that usually is a flux, because through the WebSocket you will push multiple events. You know, as a publisher we either use mono or flux. That's something we discussed in the previous lesson. So most likely you will need a flux for that. So that's why the easiest thing you can do is say flux. We can choose just for this purpose to create a flux of a finite number of events, D and E, and then use this flux as what our of course, and we need to change it so the send method, it can't receive any kind of events, of course, because the implementation behind the scenes needs to have a specific contract that represents WebSocket events. So in my case, I cannot simply provide a flux. I need to provide the flux of WebSocket message, which is basically what the WebSocket understands, and that's pretty easy because we can always just map our events to exactly the type we need here, and you do that through the session that offers you multiple methods through which you change the event into whatever event you need, and that depending on how exactly you want to send the information. You might, for example, simply use a text message. That's what I'm going to do here because I want to simply create a very simple example. But you can as well send binary message in case you want to send binary data through the WebSocket. We can simply just make it like this. So that's basically it. So that now is our WebSocket that a client can connect to, and that will provide to the client, will push from the server to the client 5 events. And that's, as I said, I'm starting with a very simple example just to test that our implementation works and to show you how to subscribe to a WebSocket and receive the events. And then I will make this a more practical example, because you might guess in the real world you don't use WebSockets like this. Like, you don't have some fixed events that you send. In a real world example, you would either have a scheduled process that generates events at a certain point, or you might have a way in which somebody else through the server, like calling an endpoint or something like that, pushes events to the clients listening to that specific WebSocket. So indeed, if you take only this example, you might find it very, very unuseful, because in the end what I created here is no different from a simple endpoint, isn't it? But wait for it, because I'm going to get to the point as well. So what I'm going to do, I'm going to use Postman. So I already have a tab here. Let's make sure that the link is the right one, because WS messages. Okay, WS messages. Okay, so it's an example. Postman is not great, but it is simple enough to use it as a client. And what I'm going to do is showing you how I created this tab, because if you don't know, from the very beginning, the idea is that being in beta, I think that's why that's the reason why, if you don't have a workspace in Postman, you will not be able to access the WebSocket request button here, which is creating the tab. So it's not difficult to create this tab. You select from a workspace, new, and then WebSocket request. But you will have first to log in. So I'm not sure why they made it this way, but you will have to log in. So Reactive WebSocket is compatible with Stomp. So I'm not sure. I think no, but I will have to figure it out if I'm right, and I will answer you in the next video about that. Because I don't think I'm not sure. Sorry for that, Glaze, but I will have to research and make sure if that protocol is fulfilled by the WebSockets implemented with the Reactive. Cool. So you see it here, the URL WebSocket localhost 8080, because I didn't change anything. It should be the default port. WS messages, which is precisely the URL. And then I connected, and you've seen what happened. In this case, it was pretty fast. I connected, I received all the events, and then because in my case the flux ended automatically, the disconnect message has been triggered, so the client has been disconnected. You can see pretty easy here that I received all the events that I was expecting to receive from the server. I connected, I got the events, I got disconnected from the server. Okay, that's fine, but again, it's not usually most likely why you will create WebSockets for. So you want to have a channel through which you can at a certain point send messages to the client. Otherwise, you won't create a WebSocket. You will most likely create an endpoint. So that means that instead of having some simple events here, we need to find a way in which we can push messages from the server to the client whenever we want that. So how can we do that? Well, of course, we have already discussed in one of the previous videos that you can create a programmatically publisher using syncs. If you didn't see that video, I do advise you rewatch the videos before coming to this one, because we discussed a lot of important things in the first 7 videos, and I guess if you don't have those, you will find this difficult, challenging to understand. But when you create a flux, one of the other possibilities, not the just method is very often used in examples, but one of the other possibilities is to have it created through the create method, which, if you do remember from one of our previous lessons, it uses a sync. The sync is basically an object that allows you to send messages. It's called a sink because it's like the water goes into a sink. You provide the messages whenever you want there, and the sink consumes them and puts them on the publisher. So it's a programmatically way to define what and when goes through a publisher, through the flux in that case. So that's what we want to use. In our case, we will need to use a sync that we can call from whenever we want. Because if I'm going to use a sync, like this is my sync here, and I'm just going to say, I don't know, let's do that just for the fun of the example, but you will see that's not necessarily very useful. I can just say in that case, say I'm going to continuously create and push some random unique identifiers using the next method. This way we at least remember how the create method looked like. So we can do something like this. Let me see what happens here. So it sees it as an object and we need to have it as a string. That's most likely because the sync here is object that I can simply say string value of here just to be fast. And if you want, you can even add a delay, say something like delay elements here just to observe them easily. So duration of seconds 1. So again, to be more precise with what I've been doing here, so I'm just creating this time of flux. Oh, and what I wanted actually is have something like this. Otherwise I would have only sent one element, which is not what I wanted. But the idea is pretty simple. So I create a flux, I continuously push elements. I created an infinite loop here, so my sync will continuously get elements, and then I can even delay them, so I can see them delayed when I receive them. Otherwise they will be very, very fast. So that's the whole idea. And I'm restarting the application, and I will try using Postman again to consume the messages. But the idea is that again we are not still in an example that relies to a production ready application. So we will need something else. We will need to figure out a way in which we can provide here a sync, create somehow a flux from a sync in such a way in which we can use the sync somewhere else to push the messages. That's what we want to do in the end. So if I'm connecting now, okay, very funny, I don't see the events for some reason, but I'm pretty sure they should have appeared. Okay, I'm not sure exactly why I don't see them, but anyway, as I said, so the idea is this is still not something we wanted. So I need to figure out a way in which I can use this sync to get messages from somewhere else. So how can I do that? So I can try, instead of this, I can try using the syncs class. And the syncs class is a way in which I will be able hopefully to create a sync, and that sync I can use it from somewhere else. So I can say syncs many, okay, and then I will say I want a multicast, which send messages to whoever connects to the sync, and then direct best effort, which says push it when you have the message. But if I create a sync here, which is possible to create, I can simply create it here. This creates an object of type syncs many. The problem is in this case that I will not be able to use it somewhere else. So I can use this sync, then I can change it into a flux, which is exactly what I want to do. But the problem is that if I created it here like this, I will not be able to use it from somewhere else. And my plan is to use this sync here to consume the values from the sync. So I will create the flux out of it and then send it with the WebSocket messages. But I want to push the values into the sync from somewhere else. And the way to do this should be simply create the sync as a bean and then inject the sync in both the handler as well as the service. So that means that in the configuration class I can simply create a bean, sync in this case, and I return the syncs many something something. Okay, sync many. string maybe, and then I add a bin above it to create it as a bin. So now this is a bin in the context that should allow me inject it here. This way, and then I just say flux from the sync as flux, map it each string event to the session text message, and then send it. So that should be what we need. But now, being that this sync is in the context, in the Spring context, it means that I can create, for example, a controller here. So let's say I create a controllers package, and inside the controllers package I will create a demo controller, and in the demo controller that will be a REST controller. I will inject the sync. Normally I wouldn't inject the sync here directly. It's not normal having the sync directly in the controller class, since the sync is used as part of a use case. It should be in a service class, and the service should be injected in the controller. But to make the example simpler and easier here, let's just try using the sync directly here. So private final sync, and then of course we can use a constructor to inject the sync, and then let's just create a demo endpoint that you call via post, and whenever you call it, for example here it will say sync emit next would be the what I want. That will be the message here, doesn't really matter what the message is, and emit failure handler, we can use the constant fail fast for that, which means if you are not able to push the value, just fail. That means that now theoretically we have an endpoint as well. So we have an endpoint, we use a sync. The sync is a singleton defined as a bin in the Spring context. So when you call this endpoint now, every time you call it, you emit the next event in the sync, and then that event will be consumed here, transformed into a WebSocket message and sent to the clients listening to that WebSocket. So if I didn't miss anything, then this would basically mean that every time I call the demo controller, it should push a message. It should push a message through the WebSocket. That could be a case, that it could be a more production-like case. The second way I've seen WebSockets used is, again, don't necessarily have an endpoint that pushes the values, but you might have, for example, a scheduled method. So method that is scheduled to run at a specific interval or at a given time, and then it simply pushes messages to whoever listens to that WebSocket. And maybe I forgot to mention, but usually to a WebSocket is the front end of a web application connecting. So you have a JavaScript code. I tested here using Postman because, as you might know if you are already following me for a long time, I'm a backend developer, so I'm not really writing JavaScript. So I don't want to give lessons on how to write JavaScript code. but the idea is that if you have an application, a front and backend application, then usually the front end will be the one connecting to a WebSocket, and then what you want to do is be able to somehow send messages from the server to the client. Like, for example, when you have Facebook open and suddenly your Facebook shows a notification, or maybe you have some kind of a live chat and the messages appear in the live chat. Anyway, so let's see if we manage to connect again. Connecting. So I have no idea why it doesn't work for me today. It says connection refused. And it's something that I'm doing wrong, but I'm not sure why. Let me try restart it. WS messages didn't change. This seems to be fine as well. Okay, now it connected. I have no idea what was the case, why it didn't connect. Maybe it was a problem with my client, with the Postman. So now I see it connected, which is good. And then what I'm going to do is start another tab and try to call HTTP. I don't think it's send, I think it's demo. This is it, demo, yes. So I press the send. It says 200. Okay, I will try to press several times, and then what we expect here is that every time I click the send button in the second tab, a new event will be pushed to the client in the first tab. So it's pretty much what we expected. You see that the disconnect event is not there any longer here, so we don't have any disconnection. That's basically because the client remains connected, and that's the whole idea now. If you have a client, you leave it connected, it's the client's choice to disconnect, but the idea is that the server now can push events to the client itself. So it's now every time I'm sending a new event through this endpoint, the event goes through the WebSocket. So now you can imagine all the use cases you can achieve with this WebSocket, because it again doesn't need to be an endpoint that someone calls. It can be that maybe it's an endpoint. When you call an endpoint, you send a specific message, but it can be simply that this is a service and this is a schedule method, and you can have a schedule method sending events at a given time. For example, it checks something and then sends a notification if something happened meanwhile. So it's a way in which you allow a client, and here you allow a client to connect and then receive events when they need to receive the events. One thing, and the last thing that I didn't discuss at all about, is the message from the client to the server, and that's literally the last thing you will need to know about WebSockets, is that you can have also messages from clients to the server and have the server act somehow for those messages, and that's pretty simple to achieve as well. And of course, as you might expect, it happens in the handle method here, in the handle, because that's why we call it a handler. It handles the messages. It basically handles the session, is the best thing to say here. But same as you send messages from the server to the client, of course, here is also through the session is also the way in which you can do the other way around. You can receive messages from the client, and maybe let me simply comment this out. I will comment it out because I don't want to create a separate project. I will put the code in my GitHub after the live event anyway, so that you can test it yourself if you want. But I don't want to have two projects because they will be basically almost identical. I will comment out this, and then what I want, one other case, and the last one that I want to show you today with WebSockets is what if you want also to get messages from the client. I've only shown you how to send messages from the server to the client. I will show you now how to get messages from the client to the server on a WebSocket. That doesn't happen that often. You might find use cases for this as well, so from client to server. Usually when you have messages from client to server and you want the server to act upon those messages, you find it more simple to create this with a normal endpoint, a normal reactive route, so you don't need a WebSocket for that. But still, if you at some point really need a WebSocket and we want also to get those messages, then you will know from now on that on this session you have a method that's called receive. The receive method gets the messages from the client, and then you can do whatever you want with them. So let's just figure out a very simple example here. Let's say, so we just map them. Let's say we map this event. We will have some text. We will get some text. By the way, you might have JSON objects. If you want to have JSON objects, you can anyway get them as text and then map them with an object mapper to any object in your application. So you can use objects and you can use them. And I would recommend using them simply formatted as JSON, because that's how you are anyway comfortable to do from endpoints, from normal endpoints. So I say get payload as text, and then maybe I want to map the text, say new string builder of E reverse, okay, and then map the event again into session text message, and that would be the new F flux we create. So this one remains commented out. So it's a string, then I have to make it to string, and then let me restart and see if I did manage to do what I wanted to achieve here. So in my case, I just said take the values you get, then reverse the text, and then put them back and send them back to the client. A very simple and theoretical example, but it should give us a good idea about what means to send the message from the client to the server. So you see here now, if I try to call the endpoint, it will work, but it won't do anything anymore because I commented out this part that is consuming from the flux in the context. But it should do something else now. Now, when the client sends a message, we should see back in Postman the text reversed. So if I say hello, I send the message, and you see it shows me this is the message sent from the client to the server. This is what the client got back from the server, which is the reversed string, which is exactly what I created there. So the conclusion being, you can have the other way around as well. But again, in most cases where I used WebSockets, because if I want something like this, I will simply create an endpoint, isn't it? I don't necessarily need a WebSocket for that. The WebSocket is in the end, the advantage it brings over a normal endpoint is that it allows the client, multiple clients, to connect to a source of data. So you might have multiple clients listening to the same topic and getting the messages. Secondly, and that would be, and if you want to take this as a homework, for example, you can try implementing a chat, like the live chat we are discussing here on YouTube. But very often you want the clients to listen to a specific topic. Not necessarily, they won't necessarily send messages themselves, but they might want to get events that happen somewhere else. And that's why we discussed about this option of having an endpoint, that when you call the endpoint pushes an event that then goes through a WebSocket to all the clients. And if you want to see that on a diagram, and again, remember that I'm only representing a client here, but you can have multiple clients. So what happens in this case is that the server exposes an endpoint. This is the endpoint. The client connected, but every time someone else calls this endpoint, the server pushes the events to all the clients listening on a specific topic. Spring Docs, you can use external brokers such as RabbitMQ. That is a totally different subject. So of course we have the possibility to use message brokers, ActiveMQ, RabbitMQ, Kafka, if you want more scalability, are very good examples. However, that doesn't mean you shouldn't use WebSockets. It's totally different technologies that you use in different architectural approaches, which apply different use cases. So I don't want to make a comparison, even though message brokers refer to sending messages and they are part of reactive architectures. They are not related to WebSockets and they don't somehow replace WebSockets or something like that. So it's a different topic. Message brokers such as JMS message broker, AMPQP, or Kafka are powerful tools, but again they will find their usefulness in different scenarios. So this lesson was specifically about WebSockets, not about message brokers. So that's on my diagram. So I have the client connected, and then anytime, anywhere, anyone, doesn't matter if it is one of the clients or someone else, it might be a different service, calls the demo endpoint, the server pushes messages to the client. So that's how you can have a situation where you get events from somewhere else. So what are the use case for using WebSocket? I think I just mentioned them. I'm not sure if you were here from the very beginning, but again, if you have for example, a front end, Angular or React.js or a Vue client, you can have the front end registering to a WebSocket, and then you will most likely use the WebSocket when you want your client to listen to events that come from somewhere else. They might come from another client, for example, like in the case of a live chat, like what you are doing here, or maybe you can listen to some different events. It can be a schedule process that causes these events. It can be an endpoint that is triggered by a separate service or by someone else. You can do a lot of kinds of integrations, but the idea of WebSocket remains very simple. You connect to a WebSocket to be able to receive events from someone who sends them, doesn't matter who that someone is. Now, in Chrome debug tool, how do we know if you are using a WebSocket? I'm not going to answer the question simply because, as I also mentioned before, I'm not a front-end developer, so I'm not the one to show you how to use, for example, a JavaScript tool or something else related to that to analyze WebSockets. I will only show you what I do from my side, which is a backend developer side. which is basically using a tool such as Postman to verify that the WebSocket works the way I want it to work. Can this make us secure, like allow only client have token? I'm not sure if I understand the question. What does that mean? Allow only client have token. I think what you want to say is, can you have only clients with a specific maybe token, maybe JVT token? I think you are discussing here about authentication, access the web service. Yes, in the end, it's very simple. As you have seen, what you did here is using an URL. So in order to connect to a WebSocket, you simply used an URL. You didn't use HTTP, but it doesn't matter. It's still an URL. And same as you do with any other paths using Spring Security, you can secure this path as well. So it's basically just like securing an endpoint. You can use Spring Security to do that, and it's the same way. Just take a look on the Spring Security playlist for that as a refresher if you need, but it's the same thing you can do here. Now, what the problem is with WebSockets, and that I will show you some alternative for that using RSocket. That RSocket is a different protocol we will discuss in one of the next lessons. The problem here is that, well, when you connect to a WebSocket, things might change in between, including access to messages. In that case, you can secure with WebSockets only the first call. So you can secure only the connection of the client, but the client can stay connected a long time. Then the question is, what if you change roles or permissions during this time? Will you be able to, I don't know, disconnect the client or do something like that? The answer is no. In that case, because with WebSockets you will only be able to secure the first call using Spring Security, same as you do with any other endpoint. That's very simple. But the problem is you can only secure the connection. And then with the messages, if for example in between the client shouldn't receive any more messages, you can't alter that. But we will discuss a different protocol that's called RSocket, and which solves a part of these problems. And I think with that I answered the question about authentication. So yes, you can implement authentication for this endpoint using Spring Security. Yeah, and with that being said, I think we discussed everything I wanted to show you. I will put, as always, the code on my GitHub. You will find it, you can use it, test it, enhance it, come back to questions if you'd like. But we've covered basically with these examples most of what WebSockets are. Thank you very much for your questions. I hope I managed to answer them. Thank you very much for being here as well, and have an excellent time for study later. Cheers, bye-bye.